Alright, we are trying to figure out which one doesn't belong. I'll address that in the next slide. So go ahead and put that wherever you think. Alright, the truth is that we have a break in this graph right here and in this graph right here, which makes them discontinuous. So the thing that we're looking for was this graph over here. It doesn't have any breaks. It is continuous throughout. And hopefully through this lesson you'll find out what in the world that means. Alright, so here's the thing you want to consider is this is the graph we're trying to study. So if you consider that we put in 1, we're going to get 1. If we put in 2, we're going to get 1/2. Well, what happens if I put 1/2 in? So 1 divided by 1/2. So how many halves are in a whole? That's 2. So we're going to get the reciprocal. So if I put in 1/3, I'm going to get 3. And for all these, we can say plus or minus. So that gives us the negative side of this as well. Okay, so we get the negative side and the positive side. So that's how the graph is created and what's going on. Keep in mind that we could never put 0 in the denominator. So we're going to get really, really close to, but never exactly to 0. So you know what? We call that a vertical asymptote. Okay, it's a vertical line that it approaches as y goes to positive or negative infinity, but never really reaches it. Okay, so it's found where the non-removable restrictions of the function. Non-removable. Well, that doesn't really make any sense, but you've done a ton of factoring in this section and in this chapter, so here's where it finally comes together. We were able to factor a bunch of things out today. Okay, so this is going to be your VA. The next part is some things do cancel out, and that's what we have in the red box here. And that is something that is removable. That is a hole in the graph. Okay, so as we list and name each thing here, okay, so we have at -4, we have a VA. At 2, we have a hole. Okay, because that part can be removed. Just like from the graph, whatever's left, we can actually remove it. Okay, so all the factoring we've done, we're still going to have a domain restriction, and then with each domain restriction, we're going to say whether it's a vertical asymptote, which means it remains, or it's a hole, which means it was able to cancel out. Alright, so let's try that out. So first thing is, we can't tell just by looking at it, so we're going to have to factor it out. So factors of 24 are going to be 6 and 4. Okay. 16, that's going to be x minus 4 and x plus 4. So domain restrictions x is not allowed to be positive or -4. Then what happens is we go back, we cancel out the x plus 4. So that means there's a hole at x equals -4. No, I didn't get it backwards. Remember, this is based on the solution. Where does the VA exist? X equals +4, because that's the one that's still part of my solution. Alright, let's factor out the next one, see what we got. I have a GCF, 4, and then x minus 4. On the bottom, we have x minus 4 and x plus 3. Alright, can we get rid of anything? Sure, x minus 4. Domain restrictions, x is not allowed to be 4 or -3. The vertical asymptote is where x equals -3 because it's still part of my solution. The hole is the thing that got canceled out. X equals 4. Okay, so domain restrictions always turn into either a vertical asymptote or a hole. Not too bad. Right? Kind of puts together everything that we did leading up to this. All right, how do you know if it's a VA or hole? So just a chance to really think about what goes where and what happens. Okay, so when you use a red dot, put it on the hole. So which one actually cancels out? Is that enough time? Okay. So the VA must be -6. Alright, now we get to horizontal asymptotes. So same idea, just work in a different place. We're going to look at the degree. So here, our degree is 1, and down here it's 1. So there's a tie. They are exactly the same. So what we're going to do is we're going to go to the coefficient. So here it was 2x over 1x. So we're going to say that horizontal asymptote y equals 2 is going to be the horizontal asymptote. So first thing is we check the degree. We find out who wins or if there's a tie. And what I mean by who wins is the top higher or the bottom higher for the degree. And we'll see that as we go through the next two. So in part B, I have a degree of 1 over a degree of 2. The degree of the numerator is less. Okay. I like to work the other way. Right? I like to say the degree of the denominator wins. Okay, so our winner is denominator, we get y equals 0. Okay, winners being, of course, the higher score. I'm not much of a golfer. Now, if the numerator wins, there is no horizontal asymptote. Okay, so we say no horizontal, but there is going to be something we have to do with that. Okay, so quick recap. If there's a tie, it goes to the coefficient. Whatever that turns out to be in their division, then that's what it's going to be, horizontal asymptote. If the bottom wins, horizontal asymptote y equals 0. And if the top wins, there is no horizontal asymptote. Alright, so what do we got? We have, don't care about these, I got 1 over 1, I have a tie. So that means I'm going to go to -2 over 1, so just -2. So my HA is y is -2. Alright, we take a look at the highest degree. The top is 1, the bottom is 2. So the HA, y equals 0. No calculation required here. And on our last one, there is no horizontal asymptote because the degree of the top was higher. Okay, so one more chance to try that idea out. So we have 2 over 2. Looks like we have a tie, so it's an HA. We're going to say y equals 3 over 1, which is just 3. Check here, the bottom wins, so it's an HA of y equals 0. Alright, and then the new one for this slide. Of course, there is no HA, but that means there must be something else. You're thinking OA. We didn't even look at it. Oblique asymptote. Okay, so we're going to find that by synthetic division, and it's just going to give us a diagonal line instead of a horizontal line that works just like a horizontal or vertical asymptote. How do we find it? Synthetic division. Alright, that's what we got in store for you right here. So that means we're going to take x minus 4. We're going to use positive 4, synthetic division. We can use coefficients, 1, -1, and -6. We're going to use addition because it is synthetic division. Drop the first one down, we got 1. 1 times 4 is 4. We're going to add these together to get 3. And we're going to multiply here to get 12. And then we have 6 left over. Now this is where it gets a little bit weird and you feel like we're cheating a little bit. But we know this is going to be 1x plus 3. This would be a remainder. For oblique asymptotes, we're just going to get rid of the remainder. So that means our graph would have an oblique asymptote at y equals x plus 3. So that diagonal line. Alright, so you're going to make a chart for your HAs. We could add in the OAs as well then. What do we do and how's that work? So we're going to try and get something on here to think about your thinking. So pause it now and get something on your chart. Okay, last thing to review in the last minute here, don't want any of these videos to get drone on too long, is x-intercepts and y-intercepts. How do we find that? We're going to use 0 to make the other one. Okay, so if I want x to be 0, that gives me a y-intercept. If y is 0, that gives me an x-intercept. Okay, so they're always opposite, so it doesn't matter what function I give you, this is always true. Okay, this is how we get some of those extra details from our equation. Right, so if we want to find x and y intercepts, some of these things you are already finding, so it's not a big deal. If I want an x-intercept, that means I'm making y 0. And if that's 0, we're going to cross this over. So I have 0 equals 1, which means it does not exist. Okay, so I'm not worried about writing those things in. The other half of what we need to do is to do all of that over again, except for I'm going to put in a 0 here. So when x is 0, I'm going to get negative 1/16. So some people like to start with that one first. So if x is 0, right, that means we're going to lose all these because it becomes 0, 0. I'm going to get negative 1/3. And if x is 0, 0, 0, 0, 0 gives me 1/2. Alright, let me erase some of that stuff out, because we have to contend with. The first one didn't work, but that's okay. Well, I said it didn't work. That just means we don't get any y-intercept. So if we want a x-intercept, we're going to make y 0. So here's what we're trying to do. I didn't show that very well, so I'm going to do this again. So I get 0 equals 1. Doesn't exist. Okay, so we already have an x-intercept, so y-intercept, okay, does not exist. So as we set this one equal to 0, and we cross multiply, we have x squared minus 1 equals 0. So we're going to find out that we're going to get plus or minus 1 along with 0 from solving that. Difference of squares. And we're going to put 0 over 1. That takes care of y, which means we're going to get rid of all this stuff. So x plus 1 equals 0. So within 3 problems we realize we're just setting the numerator equal to 0. So we get negative 1 comma 0 for our x-intercept. Okay, so that was a quick review. Thoughts, questions, drawings, anything you have for me, put them in here. That way we can review those and use that as a starting point on the next lesson.